One of the decisions you will have to make about your raster data is choosing a resolution size. We did an activity in class that has you thinking about choosing the right resolution or the appropriate resolution for your analysis, but now it's time to look at how we actually apply it in ArcGIS Pro. You may find that, hang on. There we go. You may find that you have two data sets that maybe are in different resolutions, or maybe you have a data set in a high resolution or very fine scale, but your computer can't handle the processing power. Or maybe you are trying to figure out what to do with your LiDAR data. You have a lot of choices. When you have high resolution data, like here we're looking at 5-meter data, you have a lot of options. Using a coarser resolution becomes an option. And we do that by resampling. Now, the resampling tool in ArcMap will start by looking at just the basic way you would use resampling tool. Here we have our 5-meter data. Maybe we are looking for a smaller cell size just because our computer is slower. Maybe we want to match something else. But right now, your input raster will be your DEM that you're interested in. Resampling. We'll rename it. We will select the output cell size. Now you have the option here of importing a file or adding it in. And let's think about this. Why having a smaller cell size would be good. Our 5-meter raster data, if we look at the extent, if we look at the raster information, we can see that we have 8,000 columns of grid cells by 8,000 rows of grid cells. So that, if you multiply that out, we have 64 million cells. So anytime we do any reclassification or raster math, raster algebra, it will have to go through 64 million cells, slowing us down. So if we need the data faster or we don't need this fine scale resolution, resampling our data will get fewer cells and it will make the whole process a little bit faster. So let's just say right now we don't want to match. We can just put in here we'd like to resample this to 30 meters. So I'll put that in there in the output dataset name. The last thing you have to choose is your resampling technique. Now, as a default, I always recommend when you're looking at continuous data or something like a DEM or raster surface the data that is not categorical, so it's continuous. So we have elevation with point value, with decimal points, that we have elevation throughout our raster surface. You only have two choices for continuous data. You either can use bilinear or cubic, and I find bilinear is sort of the entry point. It will be a lot faster than cubic, so again, if processing time is a concern for you, or power your computer, stick with bilinear. It's also just a good place to start. I'll put links to the documentation on it, but it has to do with the algorithm and how many cells it's taking into consideration to calculate the new 30-meter cell. So I'm going to go ahead and click Run, and we'll let that go. So we see here we have our 30-meter resampled DEM. We can check our properties to make sure we did it right. We can see now we have a cell size of 30 by 30, and now we have 1,033 rows by 1,033 columns, which if we should have looked this math up. If we look at that math real quick, we now only have 1,776,889. So a significant reduction in actual cells. So from 64 million to almost 2 million or 1.7 million. So that's faster. If we would go to, which I don't have up here, we could look at our data size and also see that our data, I should have pulled that up, but our data size would be smaller for these files. One nice thing we can do is we're looking at our resampled data here, and you can see how moving to 30-meter cells is going to impact the quality of your data and the smoothing of your data and how your data appear. But so we can see that when we have our 30 meter data, as we zoom in, that gets obviously pixelated a lot faster. We lose some of the detail from some of the smaller channels, but if you just are interested in the watershed overall, or defining watersheds overall, you'll do fine with that 30 meter data set. We also see our highs and lows have changed. Oh, that's one of the other things. With our resampling techniques, Cubic will allow data values higher or lower than the known value, but I'm looking at those and they seem to be higher or lower even though used bilinear. I'll have to check that to make sure that's right. I guess they both can. Well, never mind that then. Okay, so we saw how we can use a resampling tool if we just wanted to set the cell size to something we are interested in, maybe just to to make it larger so it's faster. We can, of course, import our data, import a cell size from another set of data if we needed to. So here's our 5 meter data. And we can, let's say we had, we knew we had 5 meter DEM, but we also had data that was 30 meters. So here we're trying to combine or do some sort of analysis between two different resolutions of data, 5 meter and 30 meter. You cannot take your 30 meter data and resample it to a 5 meter data. That is very wrong. You're getting a lot of wrong information and you should just not do it. I'm pretty sure the software will let you do it, but that does not mean you should. So our only option here is we're only as good as our coarsest resolution. So our only option here is to resample to that 30 meters. So here we're looking at vegetation health in February outside of where are we, Salt Lake City. Our cell size is 30 meters. When we turn on that 5 meter, we're, let's zoom a little bit more. You can start to see pixelation really starting to happen at those 30 meters, but our 5 meter data, we have to zoom in a lot more before we start to see that individual pixels start to pop out. But if we just want to resample to the 30 meters, so we can use all this data together, maybe for a raster calculator suitability analysis or something, we can rename it so it's something different. We're keeping our input data the same, that 5 meter, and this is where you can click on the output cell size. We can click right on that NDVI data set that we want to use, that's 30 meters. And this would adjust. So let's delete out of here. Let's change this to... so if we just wanted to resample it, you'll see it'll change automatically. If I change it to that 30 meter NDVI, you'll see it change there. We're going to keep it as bilinear, and we would go ahead and click Run, and we would get that output. So we're seeing our resampled 30 meters, since it's exactly the same as our 5 meter DEM, we're not seeing a major difference. We're seeing the exact same thing. We use the same interpolation technique. That is how you resample your raster data from one resolution to another. We'll have another video on resampling from LiDAR data and resampling from point data.